I just want to make a quick video going over number 16 from last week's assignment on Thursday. Just going to show you how to make the confidence interval, get the t-value because it's a different confidence level. But I do want to start with the fact that this is a textbook. It's a bad textbook. This was just, and well, it's not bad, but it's getting you to go through the motions of doing the confidence interval, which is the opposite of what I want us to be thinking about. I want us to be thinking about the statistics and what they tell us. And the big part is those requirements. Like, when can we actually use this? And I want you to check this out. The requirements for this is that we have a simple random sample, which I don't see the word random. I just see sample. So that's one issue. Second issue is n is definitely less than 30. Okay, n is 10 here. Might as well write it right now. That means degrees of freedom is 9. So n is really low. So the other issue, the other thing that will help us is if the population is normal, which also isn't stated here. So amounts of arsenic in brown rice. I know nothing about brown rice. Is it normally distributed? Probably. That's why the word normal is used, because it's what's normal. But we have no idea. So one way you can look, and this is like exemplary work, something that's someone that really wants to dive into the data and has interest in this, like me. Let's go look at just what the data shows us, okay? So I've taken the liberty of already typing it into Desmos. Make sure we're still recording. So I'm going to go mean of A. Boom, 6.4. That's not what I got earlier. Ay, ay, ay. 5.4, 5.6, 8.4, 7.3, 4.5, 7.5, 1.5, 5.5, 9.1. Caputo. Thank you. Okay. And we need to get the sample standard deviation at 2.32. So we're going to write those numbers down as well. So X bar is 6.35 and S is 2.32. Okay, but let's look. Let's look at the data. Does this actually fit a normal distribution? Box plots. Box plots are great. Let's go to the box plot. There it is over there. Boom. And when I first looked at this, I was like, oh no. Where should we look in this to think, oh no? Right here. That 1.5 is low, okay? But here's a little hint as to how we can check if it's too low. You use this box here. All right, so I want you to picture another box the same size going off of that. And if it's more than 1.5 of those below, then it's an outlier. But it's not, because if you just draw a box here, it's just a little bit past it. And it needs to be more than 1.5 past it. All right. So the idea is that since there's no outlier, then we basically think, okay, this had to have come from a normal distribution because it must have just pulled from the middle. The mean of this is 6.35, which is really close to the median. So it really isn't that bad. I want to make sure we thought about the fact that we can kind of believe that the population is normal and that we have our requirements. Okay. So to do our error, we need T. All right. And we got to use that 90% here. So if I go draw the T curve, which is basically normal, put 90% in the middle. That means that there's 10% on the wings, which puts 5% over here, and I got to add those. So inv T, or if you're using Desmos, you do it a different command, but it's the same idea. We're doing 0.95, comma, the degrees of freedom, which is 9. Okay, so that is 1.83. So 1.83 times the sample standard deviation of 2.32 all over the square root of 10. That error comes out to be 1.29. So to make the confidence interval, you have, let's see, you take your X bar, which is 6.35, minus 1.29, and 6.35 plus 1.29. And that gives you 5.06, 7.64. All right, so I'm 90% confident that this interval contains the true mean of the arsenic levels in rice, because that stuff is really, really interesting. Thanks for tuning in. Oops, that's the last video. Bye.